folks. I apologize for starting a minute late here. Try not to do that. And I think everything is sounding good. You'll notice that there's a chat session up there on the right. And if you have any kind of problems, just go ahead and put a message in there. I'm not sure how quickly I'll see it. It might take me a couple minutes. I'll explain that I'm running Linux. And in Linux, it's not quite as compatible with Google Hangouts as Windows is. Surprise, surprise. So in Windows, I can just share of a two-screen setup. I can just share one screen or the other. In Linux, it tries to actually share my entire like two-screen wide desktop. I've seen it work differently, but not today apparently. So what I'm doing is I have this one screen set for about 1024 by 768, or I'm sorry, probably 1280 by 766, whatever the small HD setting is. And I can only see what's on my screen. The Hangout's in the background. I do have a little, I'll go on camera here for a second. Let's see if you can see this. Hello, my name's Jim. There's my camera there. There's supposed to be a camera up here, but it's not working very well. So you'll see me staring off in this direction the whole time. And then you can't really see it. It's got some cables attached to it. There's a little Chromebook. So there's my monitor. So if you see me looking down in that direction, down to the right, that's because I'm actually looking at what's happening on the Hangout. So if I see your chat message, I'm going to see it when I look down there. Okay, that's enough preliminaries. Let me just explain real quick that I'm a student at University of Utah. I'm the oldest student in Utah, still looking for his bachelor's degree, I believe. I was in high tech for a long time. I took off for a few years to take care of my parents. I came back into high tech and found I used to be a systems administrator and a Unix guy going back to 1990. And I found I was only qualified for basically tech support. I had become a complete dinosaur. And so as you can see from the hat and the cup here, I used to work for Apple for a while. They're really awesome to work for their at-home tech support. I would recommend it for anybody looking for a good at-home tech support job. Awesome place. But it just gets old taking phone calls. And I got really interested in machine learning and big data and artificial intelligence. So I decided to go back to school, and I'm at University of Utah studying statistics and computer science. I also lucked into this great job at the Cancer Institute up there doing programming. I've got a great boss who, you'll see, I'll do a lot of my shell work in Emacs here today, a lot of file editing and showing you files in Emacs. Emacs is really awesome. So you're going to get overall an introduction to configuration of Spark. And let me go ahead and pop up a slide, and I'll explain the background here. There's a closet off in this direction, and it had a water leak, and so I moved things around in this room, and so my office is just being put back together. And we'll see if we run into a network snag. I'm actually on Wi-Fi, and I wasn't planning on being on Wi-Fi. I was planning on having a plugged-in connection, so I've got a different IP address than normal, and I think I've got it all tied off. You'll see as we go, as we get into Spark, there's a lot of considerations. I'm going to go ahead and start up the slides here. There's a lot of considerations. I've actually run into I'll just kind of jump ahead just for a second and give you a little taste of some of the detail we're going to look at. I've actually seen, I think it's an old bug in Spark that isn't quite fixed, and I think it might be related to how host files are set up. Like the default setup for host file tends to name a loopback address, so sometimes there's a bug in Spark that sometimes it doesn't resolve the address correctly. So I tend to do everything with IP addresses. And we'll see that. Today we're gonna focus on configuration and installation of Spark. We're gonna look at some of the basic programming concepts. In fact, you're gonna get to see me build a Spark file from scratch, because I realize that none of my existing files are building right now. I've got them all in various stages of development, and there's a lot of considerations. The biggest thing that my boss keeps beating into my head is that this is based on Java, so class path is of primary importance. We'll talk maybe a little bit about the whole open source environment, and then we'll get into some of the related products around Spark. If you're a programmer, you have a pretty good opportunity to get involved in a project like this. I'm a programmer, but I'm just kind of I don't have years of experience under my belt, so I'm looking for different ways to get involved. If you're more advanced, you can just jump right in and start fixing bugs. So let's go ahead and take a look. If you're going to install Spark, you want to download it and just unzip it, or use tar to open it up. Now, if you're in a Windows environment, off the top of my head, I know there's Hadoop for Windows that you have to build. I don't believe there's a Spark version for Windows. I don't believe there is. I've never seen it if it exists, but I use Windows, but I tend to be pretty much in Linux. So one of the underlying things, you have to have your environment set up right in the first place. Let's actually go take a look at the shell for a second here. Let me share my screen. Instead of sharing just an application, I'll share my screen. Give me just a second to do that. Okay, so I'm going to turn this off. I should be back on camera there. Hello. Let me go ahead and share the whole screen. And yeah, I don't see anything in chat. Actually, I'm just going to share Emacs for now. Let's see if this works. Hey, it's working now. Before this was, well, you're actually seeing not Emacs. You're seeing something about share your screen with Google Hangouts. Huh. What happened here? Let's try this again. That's funny. Try this one more time. Sorry, give me just a minute. Yeah, okay, Emacs is just not playing well. This is what's funny, Linux and Hangouts, and especially Emacs. Emacs is its own little world to itself. So there, and that's pretty cool. I love it when you see how Hangouts does that. It's like if you share the actual Hangouts window, you get the infinite loop. So let me go switch over here. This is the thing for Emacs. If you don't know what Emacs is, I'm going to kind of, yeah, it's just not going to let me share it. What is going on here? Sorry, I apologize. I had this working before, and I don't know why. Now that it's live, there's a saying your demo will fail. Let's try this again. Oh, there. You know what? You can see it. There's Emacs right there. I told you it doesn't really cooperate. So let's just do. I don't think clear is a command that works in Emacs. Let me do this. There. How's that? We'll make this work. You'll see in a minute here. It's actually going to clear up and look okay. So the very first thing that I've done here, I'm going to actually go and show you, here's the Spark website, and you see all the documentation. We'll take a look at this later. There's a download page. You're going to come in here. Now, they just came out with 1.6.0. I have 1.52 installed. I don't have 1.6.0. There's some interesting improvements in 1.60. They have something called data sets. They're kind of, you see like there's an older feature I'm pointing at down here on the lower right, SQL and data frames. Now they have something called data sets that I have not had a chance to look into. It's worth noting that Spark is built on Scala, so you need to have Scala installed on your machine. But just real quick, I'll show you. Hello. Sorry. So if I go Scala dash, I think it's just dash version. I forget if it's dash. Yeah, there we go. So I have 2.11.4 installed. I'm just going to kind of bounce around on some basic installation stuff, some environment stuff for a second here. If you don't know Linux, you're going to learn some. If you don't know Linux, you should probably get up to speed on these basics, because these are just basic things. Now, you have an environment in Linux with all these environment variables, and I want to actually do what's called a pipe here. If you're not familiar with that, that's that little up and down straight arrow or straight stick thing is called a pipe, and it redirects the output. It's going to take this output and run it through another command I'm going to do called grep. And I'll show you a couple things. I think I have a Scala home set. My boss doesn't like all these environment variables. He's kind of old school on this stuff, and he's probably right. He usually is. But I have all these environment variables set. You have to have Java installed, grep Java. So you need your Java home installed. This is critical for a lot of stuff in Linux. In Spark, forgetting off the top of my head if it was Spark or Hadoop or what required me. Something required me to install the real, not the real, but the proprietary Java from Oracle as opposed to Open Java. So when you're in Linux, there's a tendency to want to install the open source version of things, but for what you're doing here, install the real Oracle Java. There's another one here. Well, you can probably see it up there, but anyways, I'm going to just explicitly show you. You need your Spark home set. Oops, env grep. Hello, if I could just type grep Spark. So I'm not quite sure where all Spark uses this, but it's recommended to have it set. The last thing I'm going to cover is you'll notice that if I go to, I install it in user local Spark. So if I cd, actually I'm in user local Spark right now. Actually, I'm in what's called the sbin directory. Let me just, well, I'll just cd up there. Well, let me push D. And then one thing that is pretty cool, I actually used Linux for a long time. I didn't know you can actually do auto completion not just on files, but you can do it on environment variables. And so that is, right now we're in just user local Spark. And if we look here, my personal account owns, and yeah, sorry for the messiness of the screen there, but you can see the important stuff. Again, I don't know why. I'm going to blame both Google Hangouts and Linux and Emacs for this, for all not playing well together. They're all rugged individualists. So you see that I personally own everything. You'll see, I think I have Hadoop on this machine. Yeah. And now this is what's cool in Emacs. When you do file completion in Emacs, it doesn't just, it actually gives you like a separate buffer here and shows you, I have these 2 different versions installed. Let me just show you something real quick here. Oh, okay, I actually own, yeah, ls-l. In the Hadoop case, I've set up a separate Hadoop user. We're not going to get into Hadoop today, but in the case of Spark, you don't need to set up a separate user. You can just own all the files if you're just working with yourself. Okay, let's go take a look here at the slides for a second. That's not the slides. Is that it? There it is. So we talked about the environment. One of the most important things to understand is that Spark, when it does distributed processing. I guess I should have started out by saying if you don't know what Spark does, Spark is for taking programs that would normally just run on one machine and distributing them across a cluster of machines. The whole cluster idea goes back well, it goes back a lot further, but it's been really popularized in the last 10 or 15 years by Google and by the MapReduce algorithm that they developed. Spark is really basically a replacement for MapReduce. If you look at Hadoop, Hadoop is just really at its core just HDFS. It's really just the file system that's distributed. But people tend to think of Hadoop as a whole ecosystem that includes MapReduce. And so MapReduce will take jobs and split them across a cluster, but it tends to be more disk intensive. They noticed that things were slowing down because it was writing to disk too much. So Spark is really all about trying to spread jobs across a cluster of machines and keep them in memory as much as possible. There's a lot of different concerns on that. We'll make sure we talk about serialization at the end. But for now, you have to have passwordless SSH to your workers. So that's even if you're going to just run Spark on your local machine. If you're gonna run it in what's called local mode that we'll take a look at, you don't have to worry about this. But if you're going to run it in the regular like cluster, well, I don't want to say cluster mode because that has a specific meaning. But if you're going to run it in the distributed mode where you have a master and a worker running, which we'll get to pretty quick. We'll start up our master and worker pretty quick here. You have to have this passwordless SSH. So let me show you what I mean. I can go, well, for example, I have this other machine out there it's a Toshiba laptop, so I call it Tosh. And I can just, I hope, yeah. See, I can just log in there, and I don't have any, I don't have to enter a password. And the reason I can do that is because I can go in my .ssh folder, and I have these files here, these public keys, and then authorized keys, and known hosts. And so you need to, this is not the point of today's talk, but you need to know how to set up SSH, or in the Linux world, it tends to be OpenSSH. I will show you something real quick. If we go to cd, so in Linux, your etc directory has all your configurations, almost all, not all. There is something in here, and watch, when I hit the double tab in Emacs, it's going to be really cool. It brings up another buffer and shows me everything. And then as I type, what am I looking for here for? It's SSH. Come on. Let's see, I'm in Etsy. I thought there was an SSHD directory in here. Where is it? Let me just go down here and look. This is kind of not the right, oh, here we go. There's an SSH directory. Why is it not? Yeah, there it is. Okay. And then in SSH, I don't have anything here. That's really strange. That's not right, actually. I must have, yeah, there's a bunch of stuff in there. You can see SSH config. I don't think I'm giving away any major secrets if I show you my SSH config. In fact, in Emacs, I just want to, I'm kind of new to Emacs. Let me catch myself. In Emacs, you really do Control-X, Control-F, and it lets you look at a file. And here in Etsy SSH, I'm going to go SSH config, and it's going to actually let me click on this and bring it up. And I'm just going to show you a couple settings in SSH config that you need set. Now that's funny. Forward X11 is one, but there's another one here, X11 forwarding. I guess I actually don't have that in this file. But the thing that's important to look at here, sorry, let me just look at something here. SSH config. Oh, SSH deconfig. Sorry, this is what we want. Okay, no wonder it was looking so strange. You can set up what kind of host keys you'll accept. There's permit root login, probably a bad idea, so set that to no. The other important, and again, it's up to you to really get all the details of this, but you want to set your password authentication to no, so that it does a what's called a public key login. It's probably more detail than we want to get into in this Hangout. There's one more setting I really like. I'm not finding it. Here it is, right here. X11 forwarding, my favorite thing. You can actually, I'll actually show you this. Let me go to a regular terminal because I'm not sure how Emacs is going to behave. But I'm on this machine called Jim here, and if I go SSH Tosh, that's one login. And if I say, for example, xterm, it's going to complain that I don't have an open display. Now I'm not actually sure if this is going to work. I haven't tested this. SSH dash capital X Tosh. And now if I do xterm, this may not be configured right. Yeah, there it is. See that window that just popped up? This is actually this is running on this Toshiba laptop in the other room. So this is actually running on a remote server. So that'll be handy. I'll probably do any work that we need to do. This is my worker node. So I'll probably do any work on that. That's really hard to see though, isn't it? Let me see something here. Well, we'll figure something out here. I'm gonna exit that for now. But the only reason I'm just kind of spending a little time on this is because you need this SSH stuff set up at least in one direction, from the master node to the worker node, because the master needs to be able to call the worker and send it things without having to stop and enter a password. I mean, there is actually a way around that, but you don't want to really deal with that if you can avoid it. And so I'm just trying to show you some of the background. If you need to log into remote machines and you want to be able to do things graphically, I mean, I can run Firefox remotely. It might take a little while to come up, but it's on a local network, so it should be pretty quick. You see, I'm going to just get off the network stuff in a second here, but I have this up here. This is for no machine. This lets me log into machines at work. And I guess maybe this isn't cooperating, or just it's taking its sweet time. Yeah, Firefox didn't want to start for some reason. I'm not going to look into that right now. All right, let's take a look. You need to have that passwordless SSH. Then the next thing you need to have set up is your workers. In this case, I'm going to have one worker on my local machine here, which is called Jim. That's my host name, and that's also my username. And then I have that remote machine called Tosh, which has a user account, Jim. And so let's take a look here. There's a file. Yeah, you're seeing my screen? Good. I don't see anybody in the chat session there. Let me actually, you know what, give me just 1 minute to check one thing here. Let me just bring something up for you. You can look at DuckDuckGo for a minute. Actually, I just want to stop the sharing just for a second and look at something and hide it from you. What do I have? I'll be right back in about 2 seconds here. Okay, I was just looking to see if there was somebody trying to join, and there is not. Going back to screen sharing. Hello. Let's go back and share the entire screen. Echo, echo, echo. Let's get back into Emacs and start looking around here. So the next thing I was going to show you is the slaves file. Here's something really cool about Emacs. It has what are called multiple buffers. So if I go Control X, Control B, these are all the windows or buffers I have available. So I have a shell running here. I'm actually over on Tosh right now in that shell. So let me bring up another shell, Control U, I'm sorry, let me back out. Control U, Alt X, shell, oops, shell. And then it's going to actually, you have to do something a little tricky to get a second shell. Let's CD to Spark home. Let's go look at our now notice here, so there's comp is where we're spending time now. We'll be spending time over in SBin. This jars directory is something custom for my work. This does not exist in most Spark installations, but shipping jars around between your masters and your workers gets a little tricky, and we're going to spend time on that. This Hangout is probably going to go more than an hour. I'm just going to keep going until I think I've covered all the basic configuration things, but there's a lot to know about Spark, so we're not going to hit everything today. So I'm in here. I'm going to go to my conf directory. I want to go Control X, Control F in Emacs, and let's take a look at the files that are in here. So there's a slaves file. Let's look at that. The slaves file here is right now, okay, Opti is another machine I have here, but I just reinstalled Ubuntu on it last night from CentOS, and I thought it was going to be cool and have a CentOS machine around, but I don't know, I just like Ubuntu more. I'm focused on other things, and learning everything about CentOS is not on my radar screen right now. And then this is just another machine that's not in the picture right now. So let's take a look. That's the slaves. Any place you're going to run a slave, this is the local machine that we're working on right now. This is the remote machine. Let me see what we want to take a look at next here. So there's these 3 files. We looked at slaves. Now there's 3 more files of configuration that you need to be aware of. And I want to take a minute and show you the, excuse me, I want to take a minute and show you the documentation. So if you go to spark.apache.org, you're going to see, we looked at this page a little bit before. Here's documentation. I'm going to go for latest release. If you're working on an older version, you can search for older versions. Basically, you have some good documents here. There's overviews. There's very basic examples here. Maybe we'll just go run one of these examples real quick. And you know what? Let's do that real quick, because that's let's just do something. Let's go back here. I'm not going to do this in Emacs because Emacs tends to be a little funny about running things in shells. Okay, so I'm on the local machine here. I want to go. What was my command there? Bin run it. Well, I want to go be in the bin directory, or I want to be in Spark home. And then I'm going to paste in this command here. I think you can see that okay. I wonder if I can make this a little bigger. Change profile. Oh yeah, I have a profile set up for him. There we go. I hope you don't mind that ugly green font. I like that ugly green font and the slightly gray background. So yeah, you can see that better. So when we run this, we're going to actually run a program, and this should just work because it's in local mode. Okay, so it doesn't have setenv. That's funny. So when you run a program in Spark, you get all these messages, and hey, it's actually working. Look at that. And did we get an answer in here somewhere? Okay, so what this program is doing, let's take a look. The program was bin run example, and it runs this example called SparkPy. And let's just take a quick walk through all these messages. I'm probably going to do this. Let me just change this profile. Give me just a second here. You know, for the purpose of looking at these messages, I want to go back to this, and then let's run the same thing again here, because now we can actually see the entire messages. It's kind of important to have a window wide enough to read all this stuff. Okay, so we're going to just walk through this just for a minute and then get back into explaining configuration. I just felt like I was covering too many configuration details and wanted to actually do something. Okay, so it's trying to find. Now, I don't actually have a Spark env.sh set up yet, so it can't find that. Let's just make sure of that. Control X, Control F, user local Spark conf. I do have a Spark env.sh, so I'm not sure why it didn't find that, but I'm not going to get too focused on that right now. You can put certain settings in that file, and it'll actually run them before it runs anything else. That's one of your configuration options. If you look back at our slide, that's the middle one. Let's take a look here. It kind of complains a minute here that I don't have Hadoop installed. You don't need Hadoop installed unless you need Hadoop. That's kind of makes sense, right? And so it'll actually use what it says, its own built-in Java classes. ACLs, I have authentication disabled. I'll show you that in the conf file in a minute here. And then you see this is where it starts really using your network. Now, I have everything based on IP addresses. That's the safest thing to do. Depending on your configuration, you may get away. I mean, Spark is designed for host names, but as I mentioned early on, there's sort of a bug in Spark. I think there's a bug in Spark. I haven't fully verified that, but I found some strange behavior if I don't declare the IP addresses. And it might also be related to how our host files are set up at work. You see here, so remoting started. It's got this akka. Akka is one of the libraries that it uses. I think they're getting away from akka in the future, but this is what it uses now for remote connections. It's started a driver. Now it's running in what's called local mode. It's not, yeah, it's not starting a worker and a master. It's creating this local directory. I have my settings set. This is not really HDFS. This is really just a ext2 file system, but I have it a configuration parameter telling it to do its temporary writing there, so you can control where it writes its files. You'll see that it starts an HTTP server. It's starting it here. It actually is, and we'll get to this in a few minutes. It's when you're running a job locally, it runs on port 4040. That's where, if you want to go watch the job status while it's running, this, your IP address, that's my local, behind NAT on my router, that's my IP address. And then you can see here, the Spark will create something called a Spark context. That's the whole environment that Spark runs in. You make all your calls to your Spark context when you create the data structures in Spark that are called RDDs, which we'll talk about a little later. I'm actually intentionally not getting into the programming or data structure concepts yet. I'm just trying to show you in this Hangout really how to set Spark up and get it running. We'll cover RDDs towards the end. So then executor, starting the executor, you see all these messages here. These are all good. You see it's actually starting a job. It's running it in Scala. Scala is a language that you should be familiar with. I'm doing everything in Java today, but Scala is actually, when you get into more complex programs, it's really a lot better to write your Spark stuff in Scala because it's so much easier to express it. And you see all these messages going through here. I mean, here's where the rubber starts to hit the road. This task manager starts tasks. And let me explain what this is doing. This Spark Pi program, basically it's generating random numbers in the X and Y direction. Don't worry if you don't follow this because it's kind of mathematical, but it generates random numbers in the X and Y direction between -1 and 1. And then if you look at what a unit circle is a circle at the origin of radius 1. And so it keeps throwing these random numbers into your little graph of -1 to 1 on X and Y, and then it tests to see, using the Pythagorean theorem, it tests to see if the dart, I like to call them darts, the random numbers, if they're inside the circle or not. And by estimating where they fall in and out of the circle, they end up estimating what pi is. So I'm on a quad core machine here. Or I'm sorry, I'm on a dual core machine, but it thinks it has 4 cores because of the way dual core machines, have like an extra. I can't think of the word right now. You system people know what I'm talking about. So Spark thinks I have 4 cores, so it's running the jobs on 4 cores. It's done. It's now finishing the tasks here. Now, the reason I'm spending a couple minutes reading through this is because reading through these outputs from Spark is very critical when you start hitting error messages. You'll find you have to really, and this is a skill that my boss is teaching me that he's stripping some of my bad habits. I'm 48 years old and I've done some programming in my life, but never as seriously as in the last year. And I've developed some really bad habits over the years, and he kind of beats me over the head and beats the habits out of me. It's a good thing. Okay, so you can see it's finishing off the tasks here. We're not seeing any warnings. That's nice. You would hope that their demo would just work. And then let's just take a look at the rest of the stuff here. It's just basically wrapping up. It's stopping the different processes. A DAG here is an important concept in Spark. And then finally, it deletes its temp directory. So that's you just saw, if that's the first time you've ever dealt with Spark, you just saw a Spark program run. It's not a graphical program. This isn't art school or anything like that. So if you're looking for graphical satisfaction, you're not going to get it in Spark. Maybe if you do some like machine learning or something and then do some plots based on the results. But I'm going to go back to the other terminal type, although we're probably going to spend more of our time in Emacs. So let's take a look at SparkConf. I wanted to show you these configuration files. Come on, Emacs, there you are. All right, so let's actually go look at sparkdefaults.conf. This is probably the most important file you're going to work with. Let me just go Control X1. Okay, so you have all these different settings. There's also ways, let me kind of give you a quick spoiler here. I'm going to go to IntelliJ. So this is my IDE for Java. And in IntelliJ, that's Gradle. If you're into Gradle, that's great. So I've actually got the same program here, PyAverage. It's not building, so we'll probably have the fun of trying to make this work or implement it from scratch. This is a different PyAverage. This actually uses a different algorithm from a different place. Google's supposed to have a way to let me share links with you, but I don't have that working. And let me just check something super quick here. I just want to go look at the Hangout real quick and make sure I'm not missing anything on the Hangout end of things. Here we go. There it is. Nope. Echo, echo, echo. Okay, let's get back into Emacs. Okay, so in this file, the main thing I've set up here is Spark Master. I've declared it here. When I go back to IntelliJ, or you can use Eclipse. I use Eclipse, but I just found it's a little buggy. I really love IntelliJ, but I get it for free as a student. So there's a community edition, but I'm using the whatever they call it, Ultimate Edition for free. Okay, so when you come in here, this is sort of a little bit of a spoiler. You can set settings. You're going to create in your program what's called the Spark conf. It's a class that's built into Spark, and you're going to give it different settings. So you can set things on the fly here, or if you know that settings are going to be more consistent, you can set them in these configuration files. So let's start there, and then we'll get to the program. You'll see here I have spark.master, spark.local.dir as HDFS. Oh, that's interesting. Spark app ID, not app name app ID. That must be the default, I guess. I don't remember doing that. You probably don't want to set your app ID here. You probably want to set your app IDs in your program, because each program is going to have a different app name. That app name becomes important a little later, that we'll see. I run this in different places, so I pick different configurations depending on what I'm doing, and this local configuration is something we'll look at when we get into the programming side. Let's take a look at a few more things here. I'm running a serializer called Cryo Serializer. I have to remember, in fact, I have to remember to get to talk about serialization at the end of this, because it's pretty critical. We could probably spend like a whole hour just on class paths and serializations, and I might just do that at some point. You can control the memory that the drivers and executors get. I'm not doing that. I'm letting Spark figure it out. There's these class path settings. There's a whole bunch more settings. You can give it options for the JVM when it launches. And then you remember how we saw in the listing that the ACLs, access control lists, and security were turned off? I'm controlling that here. In my environment, I don't have a reason to restrict who's going to access these processes. If you're in more of a corporate or a secure environment, you're definitely going to want to have that set to be true. Let me show you where all these settings come from in the documentation. If we go here to, I don't know if they have an exact link to it. I usually just Google it, or I have it up already. Okay, here we go. Where to go? So you come here. This is the overview page, right? And then you're going to download it. It's going to show you how to run some basic examples like we did. We're not going to get into this today, but there's REPLs, read, eval, print loops that are interactive. You can do this in I'm assuming that's in Scala. I haven't actually used it. Yeah, here we go. You can run Spark interactively through a Scala shell. You can also run PySpark, which is Python. There's also RSpark. Yeah, okay. Spark interactively in an R interpreter, bin Spark R. So yeah, you can, if you're a Python or R person, you can run Spark interactively that way, just like you would with RStudio. I did a Hangout last night on R and RStudio, and then we showed off Shiny and RStudio server. So you may want to look for that on my channel if you're an R person. I love R. It's just a little funky. Let me close this. I guess I kind of came into programming from a object-oriented C++ Java side of things. So then I get to R, I'm like, huh? And then now the more statistics I learn, the more R makes sense. Okay, so it talks about running in a cluster. Talks about there's a few different environments you can run in. We'll get to this a little later on another slide. So where to go from here? Where's the configuration? Here we go. These documents should all be your go-to references when you have a question about Spark. When you're looking for general things, you're going to look at these configuration docs, the tuning guides. You're going to look at. I didn't realize this might be new in 160. I didn't realize they had a doc about building Spark using Maven. Maybe this is older. There's a cool doc about contributing to Spark. But we're going to go look at configuration. And I just want to show you dynamically loading Spark properties. It's going to show you the same thing I just showed you in my program, where you create a Spark conf object, and then you do the configuration with this. I think it's called a builder pattern in Java. I'm not sure if that's the official name for this, but that's what I know it as. And then you call a Spark context with your configuration. There is a whole bunch of things you can configure. Here's all the available properties. So we looked at app name before. You can actually tell it how many cores for the driver process to use. It still just runs on one machine, but you can, I believe, yeah, the driver in theory is just like in one place. The workers are the ones that get spread out. So, but there might be a little more detail to that I'm not understanding. So you can control memory. You can control what directory it's put in. You can control where the log files go. Class paths, Java options. We pretty much looked at most of those. But there's a whole lot more. Log rolling strategy. Log rolling, that's cute. You can create your own environment variables here. Spark Python settings. What else is in here? I'll leave this mostly. Shuffling is a real interesting concept in Spark that you need to understand. If your program gets too big for memory on your cluster, or if it does certain operations, it needs to do something called shuffling. That's better avoided. There's a whole strategy to understanding. I mean, Spark doesn't abstract everything away for you. You have to know what it's doing under the hood a little bit so you don't write bad programs. Event logging settings, compression and serialization settings. Serialization, again, is really important. Memory management. So, you can look through all these settings. I'm only about halfway down the page, and you can just see there's ACA networking settings. So there's a lot of good settings there. The only setting, there's another file to look at here. There's a spark env.sh, which I don't know why it wasn't picking up on mine. Let's go Control X, Control S. Oh, yeah, sorry, Control X, Control F. We're going to go, I can just do Control U, no, Control E, Control U, Control A, Control U. No, I thought it was going to do that in here in Emacs. It doesn't. Okay, so I'm going to go in my Spark home /conf. We're going to look at the spark env.sh now. The only thing that I've really found necessary to set in certain environments is the Spark master IP. You just need to tell your master what its IP address is and then do everything with IPs. That's the easiest way to work. I'm going to give you one piece of advice here before we start moving into some different subjects. When you start setting multiple different network-related settings, it just gets to be a big confusion of what's doing what to what. And so I get in the habit, if things aren't working, I'll strip everything out. I'll just start adding settings one step at a time. And I really find that's the best way to troubleshoot things. Is just eliminate variables. And so I had a problem where, and again, I think this is related to a known bug, but I had a problem where it was resolving the host name as the local address. It wasn't properly resolving either a fully qualified name or just a host name. And so I shut off all my configuration parameters, like Spark driver IP, things like that. And I just set Spark master IP. And then you'll see we're just about to go launch some masters and workers. And I just use IP addresses and everything worked fine. There's one other thing I just would point out in here. Stay away from Spark class path. It's deprecated. They still put it in here, but deprecated doesn't mean it's going to go away tomorrow, but it means you shouldn't be relying on it. If you're in Hadoop, you're going to start using these Hadoop configures, or if you're using, well, there's something called Yarn that we'll talk about later. You need to have that set too. Okay, let us go move on here. We looked at these three things: Spark defaults.conf, Spark env.sh, Spark comp settings. I talked about most of this. The only setting that I've found that I really need is Spark master IP. So now we're going to go launch a master. We're going to go to our Spark home and sbin. There's two things. There's bin and sbin. And they're going to run this start master.sh script. So this is really going to get, I guess this gets a little more graphical. It's not quite as boring as I implied. Come on, there's Emacs. I know I'm sharing my screen. Let's go Control X, Control B. Lets me look at all my buffers. Let's go to the second shell here. Because yeah, I think this first shell I'm over on Tosh. Okay, we're going to go CD up. We're in the Spark home directory. We're going to CD into sbin. And there are these files here. Green's kind of ugly, but I guess you can see that. There is, if you look here, this file startslave.sh and startmaster.sh. There's also files called stopmaster stop slaves, plural, stop slave, singular. And it's funny. They usually use the term worker. Slave is kind of politically incorrect these days. So, they didn't call it client slave back in the 90s. They called it client server. Oh, I mean, they didn't call it slave server. They called it client server. But yeah, they still have this artifact of slave, but slave and worker is pretty much interchangeable in the Spark world. So what we're going to do is we're going to run /. Now I have an alias set up for this. And so if we look at this, I have this alias set up, $spark home, sbin startmaster.sh. And then I'm actually telling it specifically, you don't really need to do this. This is actually the location of the default comp file, but I just tell it anyways. And then I have this alias here, sslave, which I'll run these manually, but I just set these aliases up. You could do them as scripts. It'd probably be a better approach. And just put them in your path. So spark home, sbin, start slave. And when you start the slave, you have to tell it where your master's running. Now, don't get this port confused. If you're not familiar with what this construct means here, and yeah, a lot of times my start slave doesn't work on my work machines because of this IP issue there, so I have to do it manually with the IP address, but I think it's going to work here. And you'll notice, okay, if you're not familiar with this construct, there's a host name. This is like a website. It's a local web server. It's running on port 7077. So usually a web browser tries to look at port 80, or for HTTPS, I think it's port 8080. Now, is it 443? I'm forgetting off the top of my head. 8080 is used for something else. But Spark is, by default, going to try to use 7077. But you won't actually use that. 8080 is where you'll actually find, okay, that's too many numbers in one shot. Let me show you. So if I go over here to Firefox, and I look, I think it's in a different Firefox window here. Yeah, there it is. If I look here, I had this master running before. I think it's actually still running, right? Yeah. So let me just go and I'm just going to call the scripts directly. So I'm going to say stop -slave, and I always forget to type the .sh. Oh, where am I here? Why is it doing that? This must be an Emacs thing. That is weird. It's not finding. Sorry, give me just a second here. And it's not finding that. Oh, you know what? I have an error. I have to fix an error real quick. Control X, Control F. So you see how Emacs works. I'm telling it to look for a file, and I want it in conf, not sbin. That was the wrong thing to do. Control X, K, kill the buffer. I think I actually have this open, don't I? Control X, Control B. Yeah, here it is. I screwed up. Control X, Control B. Spark env.sh. I did a set env. It's export. What am I thinking? And I'm not in VI either. So I used VI all these years, so I still try to type VI commands into Emacs. See, I just did it. Hitting colon in Emacs does not let you save the file. So just a quick Emacs tip, if you're ever in trouble, just keep on hitting Control G until you see quit down here. And now I want to go Control X, Control S for save, and it just wrote it. And let's go back to our, well, yeah, actually, let's go back to our shell. Control X, Control B to look at all the buffers. There's my second shell. And so now I'm in sbin here, and now when I go stop, well, here, I can actually just be really cute and use Alt-P. Okay, so it said there was no worker to stop. Oh, because it actually stopped it, even though it said it complained that it didn't find setenv, it still stopped it. And now I'm going to go /. I'm just using / because I don't believe this is in my path. Stop master.sh. And now when I go back to this Firefox, you'll notice that, and you'll notice it's on Jim:7077 is where it's actually listening for workers to connect, but it's the web UI part is running on up here 8080. And so you see it's unable to connect because I killed the master. It's not running. Let's make it run again. So /start master.sh. And you'll notice that it tells you that it's logging. So if you're having problems, if it comes up, you can just confirm that. People that are maybe overly technical. Like sometimes they make things too hard. They would go look in a log to see if it launched. Now don't go look in the logs to see if it launched successfully. Just see if it launched successfully. So there it is. It launched. But you'll notice that if it didn't launch, you have some logs here, and I don't know why they don't just say, Spark home/logs. This is not such a horribly long path. It's actually just, if you look, ls ... up one directory into conf, and then there's all these, sorry, not conf, logs. There's all these logs in there, right? And you can see -l ../logs. You can see that they were, okay. You can see that they were written, well, it's Saturday morning, January 9th. It's 10:47 a.m. And you can see the last log was just written at 10:46. And you notice that they start with Spark. They're all the same up to here, and then they start saying master or worker. This is because I'm running both a master and worker on this machine. I'm not running a worker yet. I'm just about to do that. So just recapping here. Here's our master. You can see what's going on. You notice down here, there's no registered workers. We need to fix that. So we're going to be in the same place here, user local Spark, my Spark home /sbin. And I'm going to say /start slave. I'm going to make a script called start worker. I don't like that, start slave. And if I don't give it a parameter, it's going to complain. The usage needs to be followed by Spark. I can, in theory, use localhost. Let me bring that command up again. So you have to give it, it's not HTTP, Spark is actually a protocol. If you're using Yarn or Mesos, you would have something different there. Spark : / I'm just going to type it out. Well, you know what? Let me just take my chances. Something key to pay attention to here. This is exactly what it's broadcasting on. So I know if I just copy that and come over here and paste it, which is Control-Y in Emacs. So I guess Emacs uses what this stuff always was before there was anything like a Macintosh to have Control-C or Control-V. And I need to do that, and I need to go : 7077. And I start it. And again, we're not going to go look and see if it failed in the logs. First, we're just going to go look and see if it succeeded. And sure enough, there it is. It succeeded. The workers have their own web UI. You'll see why this is useful in a few minutes here. So there's the web UI. There's the master UI. There's the worker UI. Let's go ahead and try to start up a worker. I mean, we technically have a cluster of one machine going right now. We technically have a distributed processing system ready to accept our commands. You know what I think I'm going to probably do here? It's 10:49. I'm probably going to wrap up in the next 10 minutes, and then I'll start. Excuse me, I got to stretch here. Then I'll start an impromptu Hangout and actually work on some programs. So I apologize. I should probably realize that everything always takes longer than I think it will. Yeah, I'm usually pretty good about that, but not today apparently. And yeah, I'm going to go 10 more minutes and show you the configuration stuff, and then I'll actually stop this Hangout and then start another one. And we'll go for maybe about half an hour or 45 minutes. And that's going to be more of a hacking Hangout. That won't be, we'll see if that one survives long term. This one's going to survive long term as an archive. So if you're watching later on, I appreciate your watching. Okay, back into context here. I have my master running. I have my worker running. I want to now go, well, let's see if I can do this in Emacs. It's funny, I haven't figured out why. If you know why, please email me. At work, my Emacs doesn't show colors, and it shows all kinds of unprintable characters or non-printing characters, and I think I just don't have my color set up right. Here it works fine. Let me go to this other machine, which is in a different buffer, I believe. Control-X, Control-B shows me my buffers. Where's my default shell? There it is. Yeah, we're over on Tosh. Host name. Yep, we're on Tosh there. Yeah, see, look how this one's actually showing these little... I haven't exhaustively tried to fix this problem, but if you know how to fix that, please let me know. And what I'm doing over here is seeing... now, I was showing you SSH before. Now I want to go CD. Do I have a Spark home set up here? I do. I want to go into SBin here. And keep in mind, we're on a different machine. I'm running on a machine called Jim, but I'm remotely logged into a machine called Tosh. It's in the next room. And I'm in the user local Spark on Tosh. I'm going to actually just check something real quick here. I'm going to do something sort of unusual. I'm going to use more within Emacs because I'm on a different machine, so I don't think I can. I'm sure there's a way to do it, but I don't know. I don't know how to look at the remote file system. I just learned today how to sudo edit things in Emacs, and so I want a more conf, and I wonder if I just did a control. That's interesting. I bet you if I just tried to open it from here, it would, with the control X, control F, it would edit the remote file. That doesn't seem right though. So what I want to look at here is Spark env Spark defaults.conf. And I have a very short one on that machine. This is the entire Spark defaults.conf on this other machine. And everything is turned off. The only thing is I have the master declared there, but I don't think it's going to use that setting because I'm going to actually use that setting on the command line. So what we want to do is /start, and you look at all the different things that start. You have start all, start master, start slave is what we're after. There's a Mesos settings here. I don't know what the history server is. I suppose I should learn about that. So I want to start a slave, and I want to go Spark : well, I'm just going to try Jim. It seems like it's working for me today. It doesn't always work. 7077. And let's find out again. Let's not go look at logs to see if things work. Let's look at logs when things fail. So when I come back here to my master and I refresh it, well, you know what? It failed. So you're going to get to see a little bit of debugging. Let's take a look. So I'm going to go Control X, Control F, logs, and I want to look at the first worker out. Every time it runs, it bumps each file name up in a number. So this is the oldest one. This is the newest one. These are when I've run masters on this other machine. This should be the file from right now, and we can confirm that by seeing that it's from 10:49 this morning. So what's happening here? I think it doesn't like, well, it says it's successfully registered. What is going on? It says it's successfully registered on Spark. And there it is, and it's not showing it registered. That's very strange. It's a mystery to me. I don't know what's going on here. It says it's registered. Control X, Control B, shell. If you're really looking to see if the worker's running, there's better ways to do this. If you just do a ps-aux or ps-aux and grep for worker, you're going to get a bunch of stuff. Yeah, there's no worker running there. If you have, like, I've had times where there's like seemingly hundreds of little worker processes that has nothing to do with Spark. So if you just give it anything other than kworker, I tend to use just to give it something different, and I use ps, aux, grep, and I give it a regular expression that starts with a dot, any character, and then worker. And there's no worker running. So what is going on here? This is a little bit unusual. /start, and if this doesn't work, I'm just going to just run something on the cluster without this second machine. But I really wanted this to work for you. So let me try something. Spark : /192.168.10.14. That's my Jim where my master is running. 7077. Oh yeah, hello. It would help if I was actually, well, I'm in SBin. Oops. You have to do control. You have to do one thing that's confusing to me until I figured it out is you have to do 2 control C's in Emacs. I'm in SBin, pwd. What did I do? Start worker.sh, start slave. Hello. There I am trying to be politically correct again. I'm sure there's a fancy way to use regular expressions, but I'm just going to cheat. Start slave.sh. Okay, and let's just do the PS. Yeah, it looks like I have a slave running now. Let's go back to the other machine. Take a look. Yeah, I would have to dig deeper to explain what happened there. Why the log said it had worked. Let me just I read things too fast. That's one of my problems. Let's go take a look at that log again. I'm going to just spend 15 seconds on this. Shell, more. Where's that log? Oh, that's right. I wasn't doing it that way. I'm doing it Control XF and logs. Let's look at worker out. That's the one from 1049 registered. Okay, unable to load native Hadoop library. That's normal. You notice it's changing ACLs to Gem, but then it says security is disabled, like we looked at before. UI ACL is disabled. Logging starts listening. It resolved Gem to the proper address. I don't really understand why that said it worked and it didn't work. So I'm sure I'm missing something, and the smart person out there watching this can email me and tell me what I missed. I've only been using Spark for about a couple months, and really just the last month intensively. So I have a lot to learn. Okay, but now we have this cluster running. We have 2 workers set up, one on 10.11, that's Tosh, one on 10.14, that's this machine, and then here's the master running on 10.14. So we're really ready to jump into the next step here. We walked through this. Now, just to mention again, if that slaves file is set up in the configuration directory, you can actually use start-all, and that'll start your master, and then it'll step through and start slaves on every machine declared in the slaves file. You can look through the script and see what it does. Otherwise, you see the process we followed. We SSH'd over to Tosh, the machine in the other room at the worker node, and we went to Spark Home and ran start slave. We checked to see if it was properly registered. We looked through some logs, and the logs exist on the workers and the masters, and I don't think we've run a job yet, so I don't think we're going to get to see this yet. Yeah, we haven't run a job, but when you actually run jobs, you'll see another interface, and it'll actually show you the standard error and standard out. You know, like I said, I'm going to actually cut this off in a couple of minutes here and wrap this up as the configuration. I think you have a pretty good, if you already knew Spark, hopefully you picked up a thing or two that you didn't know. If you think there's a better approach to all this than I have, there's always many ways to do things, so I'd love to hear any kind of comments about that. I really would, if you must be watching this on YouTube, most likely. I would appreciate it if you would subscribe to my channel. It's a brand new channel. I'm trying to build this up as part of a business initiative for a machine learning company that I have to start. And I'm trying to do education and building some online presence. So if you would help me out by subscribing to my YouTube channel, I'd really appreciate it. We're going to actually shut this Hangout down. I don't see any questions out there. That's probably a good thing because I want to cut this off at 11 o'clock and we're 1 minute away. So in the next hour, when I start up another Hangout, I'll post it on my Plus page and get it started maybe in about 15 minutes and go till about 12:15 Mountain Time. So we'll take a 15-minute break, and we'll actually get a good dig into my IntelliJ IDE. We'll look at some programs that I have some bugs in, and kind of work through the bugs and look at the whole environment. And I'll probably spend some time looking at Gradle because some of my problems are in my Gradle files. If you don't know what Maven and Gradle are, and you work with Java, you really need to learn about Maven and Gradle. I would say the biggest thing my boss has taught me is that you cannot, as a developer, depend on your IDEs. You can't depend on Eclipse and Gradle to do everything for you, because as soon as you have a trouble finding a dependency or just have something going on, if you can't build from the command line and understand everything on the command line, you're not as talented as you should be. And again, I have bad habits that my boss is stripping away from me by figuratively beating me over the head in a good way, and we're going to look at some of those things in the next hour. So come on back. Like I said, just look at my Plus page in a minute here. I'll start up another Hangout and then go live about 11:15 or maybe 11:20. We'll see how long it takes me to come back. And I really appreciate it. Let me go back to the Hangout. And I hope, and let me just say one last thing. I did another Hangout from Linux, and it wasn't working very well because the audio, there we go. Oh, and I forgot to mention, there's going to be a model railroad back there probably the next time I do a Hangout. So, sorry, I'm in transition. Last time I did a Hangout from Linux, I'll just make this my goodbye message. The audio was horrible. I was able to, I have these headphones here, this little earbuds. And I think I'm still sounding okay. Good. So I had to kill that other Hangout because the audio was so bad, but this should work out pretty good today. And I really appreciate everybody that's come to watch this video. Please share this with your friends. And I'd love any kind of feedback. This was kind of an impromptu Hangout. I just put the slides together at the last minute. Future Hangouts, I have one planned on Tachyon sometime in February. Look at Tachyon and maybe cover Hadoop and some other subjects. I'd like to, more towards the summertime, get into some Hangouts and do a whole series in the summer on machine learning concepts. So once we build up the essentials here of infrastructure like Spark, then we'll get into what you can actually do with this stuff. We'll do some more in-depth stuff with R and statistics. We'll do some machine learning Hangouts. And I should have a nicer background with little trains running around a track. That'll be kind of cool. And maybe some better slides. So, hey, I'm open to any suggestions, and please sub my YouTube channel. Have a great day. Thank you.